You see terms like ICBM pop up in the news all the time, and yeah, they sound pretty serious. But what is a ballistic missile really? How does it actually work? Well, it turns out the journey it takes is one of the most extreme and frankly fascinating feats of engineering out there. So let's break it down. To really get what a ballistic missile is, it's actually super helpful to start with what it isn't. And the easiest way to do that is to compare it to its famous cousin, the cruise missile. And this is the perfect way to think about it. A ballistic missile is basically launched like a cannonball, or yeah, a baseball thrown into space. It gets this one enormous, violent push from a rocket, and then it just coasts. It follows this big, predictable arc all the way to its target. A cruise missile, though? Totally different. It's like a little robot jet. It has an engine that's running the entire time, and it flies low and slow, right inside the atmosphere. So there you have it. Once that initial, incredibly powerful rocket burn is over, a ballistic missile is just an object in freefall, a very, very fast object falling with unbelievable precision. The whole game is getting that initial push and that arc just right. Okay, so let's actually follow that journey. We're going to trace the path of an intercontinental ballistic missile, an ICBM, all the way from its silo to a target thousands and thousands of kilometers away. And this whole trip happens in 4 very distinct stages. First up, you have the boost phase, which is this incredibly violent climb. Then comes the post-boost phase, where the missile releases its precious cargo. After that, we have the longest part, the mid-course phase, a long, silent coast through space. And finally, it all ends with the terminal phase, a fiery, high-speed re-entry. Let's dig into each one. The boost phase is all about one thing: raw, brute force. This is the only part of the flight where the engines are actually firing. Huge rocket boosters ignite, pushing this thing up through the thickest part of the atmosphere and giving it every bit of speed it's going to need for the entire rest of the trip. And this right here is the powerhouse that gets it done. Most big ICBMs use what are called solid rocket motors. Basically, the fuel and the oxidizer, everything it needs to burn, is pre-mixed into a solid block. Once you light that fuse, it just goes, burning incredibly fast and generating a truly massive amount of thrust to hurl this multi-ton vehicle towards space. And here's what's just wild. This whole powered flight, the only time the engine is on, lasts for just 3 to 5 minutes. That's it. In less time than it takes to make a cup of coffee, the missile is already over 150 kilometers up and screaming along at about 7 kilometers a second. After that, the engines are just dead weight. So what happens next? We enter the post-boost phase. After the main rocket stages have fallen away, a much smaller vehicle, which people often call a bus, takes over. It uses tiny thrusters to make really fine adjustments to its path, and then it starts deploying its passengers. Not just one warhead, but usually multiple warheads, plus a whole bunch of decoys designed to confuse anybody trying to shoot it down. And that brings us to the longest leg of the trip, the mid-course phase. For an ICBM going from one continent to another, this can last for about 20 minutes or so. All those warheads and decoys are just coasting silently, weightlessly through the vacuum of space, perfectly following that ballistic arc that was set up minutes ago. And when I say coasting, I mean they are moving at a speed that's almost impossible to wrap your head around. We're talking 24,000 kilometers an hour. That's about 15,000 miles per hour. That is so fast, you could cross the entire United States, coast to coast, in about 12 minutes. Now, all those passengers released by the bus don't just stay in a neat little line. They spread out, creating what's known as a target cloud. And this cloud is a defender's absolute nightmare. It's this massive swarm of objects, miles long, and hidden somewhere inside are the real warheads. Trying to find the needle in that haystack at 15,000 miles an hour is, well, it's one of the hardest problems you can imagine. All right, finally, we hit the last stage, the terminal phase. This whole thing starts the second those warheads slam back into the upper atmosphere. This is the final, dramatic plunge toward the ground, and it all happens in less than 60 seconds. Now, hitting the atmosphere at that speed is like hitting a wall of air. It creates incredible heat and friction that slows the warhead down. But even with the atmosphere acting like a giant brake, it's still traveling at over 3,200 kilometers an hour when it reaches its target. So, after watching this whole epic journey unfold, there's a pretty obvious question, right? If you can see all this happening, if you can track it, can you stop it? And that is the billion-dollar question behind all of missile defense. So yeah, how do you stop it? Well, you can try to take a shot at it during any of those 4 phases we just talked about. But here's the catch. Each phase comes with its own absolutely massive challenges and trade-offs. As you can see, there's just no easy solution here. Hitting it in the boost phase, that's the dream scenario. You take out the missile, the warheads, the decoys, all in one shot. But you have a tiny 3 to 5 minute window, and you have to be parked right next to the launch site, which is difficult. Okay, how about mid-course? You've got more time, about 20 minutes, but now you have to deal with that giant target cloud and find the real warhead. And finally, you have the terminal phase. This is your last desperate chance. The good news is the atmosphere helps filter out the lightweight decoys, so it's easier to find the real target. The bad news, you have mere seconds to do it before impact. Now, it's important to remember not every ballistic missile is an ICBM designed to cross the globe. The physics are pretty much the same, but the scale and the reason for building them can be totally different. Generally, we break them down by how far they can fly. You've got your short-range or tactical missiles used on a battlefield. Then you have medium and intermediate-range missiles, often called theater weapons for regional conflicts. And then, of course, you have the big ones, the intercontinental or strategic ballistic missiles, the ICBMs, that can reach literally anywhere on the planet. And that kind of brings us to a final, really interesting thought. For more than 70 years, this predictable, arching, ballistic path has defined what a long-range missile is. But now, we're seeing the rise of new hypersonic weapons, things that can maneuver and skip along the atmosphere at incredible speeds. And it really makes you wonder, is this whole ballistic journey, the one we've just followed, about to change for good? That's a deep question and probably one for another day.